Hi everyone. In this video, we can solve velocity diagram of a quick return motion of the crank and slotted lever type shaping machine. In the shaper machine, if you observe this image, there is a slider moving along this slotted, and again it will rotate on this path. That means if you observe here, there is a point B and point B dash. B dash will be moved along this slot, and B is the crank, it will be rotate about point A. First we can find out what is the linear velocity of crank, which is AB. If you see here, AB value is 100 mm and it rotates at 60 rpm. Velocity of B with respect to A is equal to AB into 2 pi n by 60. AB length is 100 and 2 pi n value is 60, which is equal to 200 pi. Here it is represent in the velocity diagram is AB. 200 pi is equal to 628 mm per second. Now I will take the scale as 1 centimeter represents 100 mm per second. For 628 mm per second represent approximately 6.3 centimeter. Now we can draw velocity diagram. Now I will start with point O comma A. Here O comma A is the fixed support. Now here the crank AB is rotating in a clockwise direction. That means here the velocity of B is in this direction. Draw a line perpendicular to AB. This length will be 6.3 centimeter. Now this point will be B. After that, we know the point O on the velocity diagram. O is connected with C point. Draw a line perpendicular to OC. This is the line OC. Now as I mentioned, B dash is moving in this direction, because this is the slider. Draw a line in this direction. This line will be intersect OC line at this point B dash. Now we can identify the point C. You can take the ratio OC upon OB dash, which is equal to small OC upon small OB dash. Here we know the OB dash value. We know OC and OB dash. From that you can calculate what is the OC length. Okay, I am assuming that the C point will become somewhere here. Once you can get C point, draw a line perpendicular to CR from point C. This is the line perpendicular to CR. Then R is the ram, that means slider. It will move along x-axis. Draw a line parallel to parallel line from point O. The intersection point will be R. Now I can erase the extension lines. This is the final velocity diagram. Now if you see, what are the things that we have to calculate? Velocity of ram and angular velocity of the OC. Velocity of ram is capital R is equal to OR into scale. Measure the length of OR, multiply with your scale, that will give the velocity of ram. The angular velocity of OC, which is equal to velocity of OC upon link length of OC. Velocity of OC is equal to measure O to C distance into multiply with the scale, divide with OC link length, which is given 400 mm. From this you can get angular velocity of OC, which is equal to radian per second. This is the solution for given problem.